So I've changed the numbers, but you're going to do the same type of thing I'm about to do. For part one, they ask us to find the maximum height, and the height of a projectile is modeled with this equation. Okay, because there's two real things that fluctuate when you're launching a projectile: the initial velocity, how hard it leaves the cannon, and the angle that you set that cannon at. Because how far you launch this thing depends if the cannon is at like a 60-degree angle, or if it's at a really narrow angle, it won't go as far, right? Because it's got less time to hit the ground. Okay, so that's modeled by these trigonometric equations, and there's stuff online to see where these formulas come from too. But all you have to do is plug in this information. 30 goes in for V, so the height is going to be 30 squared times sine squared 60 for theta. That's all over 2 times, we're using 9.8 because we're in terms of meters, right? So the gravitational pull is 9.8 meters per second squared. I'm pretty sure. I should have done more physics when I was in school. So yeah, just a heads up, if you're going to be a math major, make sure you at least do physics, okay? Because nobody told me that, and I actually never took a physics class, so I've been drowning ever since. So this sine squared thing, that's shorthand notation for this, sine 60 squared, and that's confused math students for years, okay? But that squared on top of sine means figure out what sine 60 first is and then square it. So 60, I'm going to do sine with my calculator, and I'm going to square that result. So that's what this is. I found out that it's 0.75. I'm going to multiply that times 30 squared, and then I'm going to divide it by 2 and divide it by 9.8. So I got a height of 34.43 meters. Okay. So part two, same thing, 30 meters per second, 60 degrees. They're asking how far horizontally it will travel, which is modeled by this equation here. So you're plugging it in. 30 in for the initial velocity. And that's 2 times theta. So 2 times 60 is 120. Let's divide by the gravitational constant of 9.8 meters per second squared for acceleration. Okay, so 120 sine, that's one of our special triangles that we'll do several times throughout this year, throughout the semester. So that's 779 for the numerator divided by 9.8, so that's 79.5 meters. We're expected to travel 79.5 meters. And then for the last part, there's two tanks in a video game. They're 60 meters apart. I changed the number. So 60 meters from here to here. And then this height in the middle, you can't really see with the black on black, huh? The height in the middle is 30. So really you're just trying to play around with some numbers until you get two sets of numbers that allow you to land exactly on this tank. Okay, so one piece of rationale you can have is that there is a minimum theta that you need, right? Let's say this is 30 meters, so this is the height of the hill that's between us. And then if they are, and the assumption is that the hill is directly in the center. I should say that somewhere in there. So if they're 60 meters apart, that means it's 30 over here, 30 over here. So hey, that's one of our special triangles, right? Isosceles, because two sides are the same. So that means this is a 45-degree angle and this is a 45-degree angle. So for the triangle I set up, you have to have at least a 45-degree angle to clear that hill, because you're not shooting in a perfectly straight line. Gravity is pulling your shot down. So you start in a straight line, but then gravity is slowly pulling down the projectile. So that'll definitely hit the hill if you put 45 degrees. So that gives us some intuition on a guess for the height. Let's say the height is, I'm just going to pick 80 degrees. Really making sure, oh wait, sorry, that's height. Theta is what I want to adjust. I want to pick theta, 80 degrees. I get to choose a velocity that I want. Okay? The velocity can be anything, but it has to be it can't be anything. It has to be the right velocity to hit tank 2. And so what I can do is I can go into this equation up here. I know that my horizontal distance is supposed to be 60 for my problem. R equals v squared. So here's the formula. R equals V squared sine 2 theta over G. I know I have to land 60 meters away, and I've picked a theta. I'm going with it. I picked 80 for theta, so 2 times theta would be 160 in here. That's still divided by 9.8. Look, now I have something to solve for V. Okay, if I multiply both sides by 9.8, it's 588. We can figure out what sine of 160 is. 0.342. Everybody knows that, right? Right off the top of our heads. JK, LOL. That's V squared times that stuff. So to get V squared by itself, I'm going to divide 0.342 from both sides. So I get 1719.3. I think I got that right. And then I'm trying to solve for V, so I need to take a square root of both sides. We know that in trig because we use the Pythagorean theorem, right? So square root both sides, so we get a velocity of 41.46. Now we can just test that. We've set it so that a velocity is 41.46 and a theta is 80. And if we solved our equation correctly, that will land us exactly 60 meters away horizontally. To make sure that we clear the hill, we want to just plug our information in back into this H equation. So I'm plugging in 41.46 for the initial velocity, 80 for theta. We need to make sure we clear the hill. So 80 is our theta, so sine of 80. I'm going to square that result times 41.46. I don't remember if that was exactly it, but it's pretty close. Then divide by 2, divide by 9.8. So we're going to hit a height of 85. We're going to clear that hill. We checked our guess of theta of 80. 80 gave us this for a velocity, and both those together, it's enough to clear the hill of 30 meters by a lot. So we're good to go.